Gateshead and Newcastle are connected across the River Tyne by 10 bridges. The youngest is the Millennium Bridge, a slender, graceful arch, like a huge eyelid, which first opened in 2001. The oldest is the mighty High Level Bridge, a massive feat of engineering graciously opened by Queen Victoria back in 1849. It was the first bridge in the world to combine road and rail on 2 decks. It is a Grade 1 listed structure. It is iconic to every true Geordie. And yet in 2001, they allowed a load of people in hard hats and reflective jackets to start knocking 10 bells out of it.
It was built to last till the end of time, with a foot each side of the River Tyne. But the trains done rattled and the traffic rolled, and the High Level Bridge was looking over. Don't knock it, knock it, don't knock it. Ooh, fix it, fix it, fix it. You can't scrap it. Please, you gotta fix it, fix it, fix it.
The truth is, the High Level Bridge was showing its age, all 152 years of it. So what started out as a programme of emergency repairs unexpectedly turned into one of the biggest restoration projects ever undertaken 26 metres above a major river. 7 years and £42 million later, the High Level Bridge today looks as beautiful as when it was first built. This is the story of how it was done, and believe me, it was far from easy. For a start, it's a unique structure, so it had unique problems. And as a Grade 1 listed structure, every nut and bolt had to be respected. Nothing could be altered without permission, and everything which could be preserved had to be preserved. It's made up of 6 cast and wrought iron spans sitting on masonry piers. Each span is made up of 4 parallel tied arches, supporting an upper deck and a lower deck. The decks are also supported at intervals by cast iron columns, which are joined to the arches and also prop up the upper deck. Trouble is, cast iron is a bit weak under tension. So the designer, Robert Stevenson, hung the lower deck from the upper deck using stronger, less brittle wrought iron hanging rods hidden inside the cast iron columns. It streamlined the appearance, but it created a heck of a headache for the restorers, as we'll see later. Trains run across the upper deck, whilst on the lower deck, buses and taxis run between the inner arches, and pedestrians stroll between the inner and outer arches and get a lovely view of the river. One thing that surprises everybody is that both the road and the footpath were made of timber. Of course, when the bridge was built, railway engines weighed only a fifth of what they do today, and the road traffic was just horses and carts. Anyway, back in 2001, the idea was to just strip a bit of paint, patch a few cracks, Bob's your uncle. Well, a bit more than that, but you get the picture. Running repairs. So they began with tests, by close visual inspection, by using a clever system where a magnetic charge draws a solution of iron filings towards any defects, with ultrasonic tests which looked deep into the structure, and they even took x-rays. What all these tests indicated was enough to make even the toughest navvy turn pale. To confirm their suspicions, they removed some of the beams from a less used part of the bridge and sent them to the metallurgical lab at the University of Manchester, where they were tested to destruction. From this, they could calculate the strength of all the other beams, and then, in the interests of conservation, they rebuilt the test beams and put them back, where they wouldn't have to carry any serious weight, naturally. Meanwhile, they set about working out just how much stress the bridge had suffered over the years, by calculating every train and passenger and freight movement since 1849. A massive job, which they did with the help of the National Archives in Kew. Once the boffins and engineers knew the actual strength of the bridge and the amount of punishment it had taken over the years, they concluded, to put it into technical terms, that the bridge was knackered. But not quite as knackered as some people had feared. They now realised that with careful planning it would be possible to repair the bridge without destroying any of its historic character. But to do so would mean checking and, if needs be, fixing almost every nut and bolt, every girder and truss, the rail deck, the road deck, and all the drainage, the lot, starting right away. For safety and to keep rubbish from falling into the river, they encased the bridge in a network of scaffolding and sheeting. They also put a honeycomb of scaffolding inside and floored the lot with planks. So that's 1,600 tonnes of scaffolding and enough planks to cover 2.5 football pitches. Then they got down to grit blasting away 33 layers of paint. The bridge has been painted 17 times in its life, in a range of tasteful colours from green to blue to battleship grey. But these guys didn't stop there. They were going back to base metal. Up above, the trains carried on running, as Network Rail insisted that they should do right throughout the job. So most of the repairs to the upper deck had to be fitted in at weekends, when the trains could be diverted. And there was a lot to do. For a start, the longitudinal girders were cracked, so they were repaired with steel plates and glue. In many cases, they were also strengthened with an extra bracket. Back in the 1890s, they'd added some strengthening using Swan's neck girders, but many of the bolts had corroded, so the contractors replaced every single one of them. They did the same for the connecting bolts between the deck posts and the columns which supported them. And in some instances, new brackets were fitted as well. Up on top, facing the worst of the elements, most of the balustrades were damaged. Wherever possible, the cracks were filled and the surface repainted, but in the worst cases, the ornate castings were replaced with perfect replicas cast locally. And that goes for these rather nice roundels, many of which were just about to fall off. And the decorative fascia panels at the tops of the columns. Now, while I've been talking about filling and gluing, you might have been thinking polyfiller, gaffer tape. Well, don't worry. The techniques these blokes used are so advanced they weren't around even 10 years ago, and some techniques were developed especially for this job. Take the gluing. Steel or carbon fibre plates are permanently fixed to the original metal using glue that has to be applied in exactly the right heat and humidity to achieve a perfect bond. And getting the right climate over the Tyne on a perishing February morning is a challenge in itself, believe me. As for the cracks, it was just like a nurse in A&E sewing up wounds. They'd drill a perfect row of holes either side of the crack, then bridge it with immensely strong stitches made of ductile high-tensile nickel alloy. Honest, once they're ground down and the cracks filled, you'd never know it'd been mended, which pleased the conservationists, because they wanted to retain as much of the original cast iron as possible. Look at this, a complete corner cut off a column and a new one stitched on. Brilliant.